What's up, you data friends? It's Yanis here and welcome to my channel. Now please note that this video is actually video part 2 of the machine learning decision trees series of videos where we explain how to run decision trees, random forest and extreme gradient boost. So if you haven't watched video part 1, I would suggest watching that first before watching this video. In the first video, we went through the packages we need for this tutorial, the machine learning process we're going to follow, what's the problem we're trying to solve, how to load raw data into Python. Then we went through the data pre-processing phase. Then we've explained how to split the raw data in X and Y. Then we went through how decision trees work, and then we've run decision trees, and then the different ways of evaluating decision trees. In this video, we're going to go through how to run random forest and then how to tune its hyperparameters to improve our results. Then we are going to explain how to run extreme gradient boost and how to tune its hyperparameters to achieve better results. Then we are going to evaluate our models. And at the end, we are going to deploy our model on completely new unseen data. So we're going to pretend it's a business scenario where the business comes in with new data and they want us to predict who are the customers that might churn in the future and the probability of them churning. So this is what we're going to do at the end. And then we are going to export our results back in SQL or in a CSV file. And after this step, we are going to deploy our results into these Power BI dashboards. So I'm going to explain you how to build this, where the business can see the results of our models. So the people we are predicting that are going to churn, the most important variables affecting their churns, and then a customer details table where they can specifically see the people and then our predictions and the probability of them churning. So they can just filter on churns above here, or they can filter the probability more than 50% or between 40 to 100, and then focus on these people down here and trying to make them stay in the business. So not churn, trying to retain as much business as possible. Right, and before we start this tutorial, let me just say that if you're new to my channel and you're passionate about data science, then please consider liking this video, subscribing to my channel, and enable notifications for my future videos. Right, starting from where we left it in the last video, the first thing we have is some notes about random forest. So random forest is an ensemble classifier that consists of many decision trees and outputs the class that is the mode, so the most common of the classes output by individual trees. So what this means is that instead of running a single decision tree like we've done above here and set the random state at 1 so we can replicate the results, what random forest is going to do is that it's going to run 100 decision trees like this one with random states, with random states, so a lot of different cuts, and it's going to select the class, so age, number of products or members, that is the mode, so the most common out of those 100 decision trees. And the way to calculate the entropy or information gain is that it averages the entropy or information gain out of those 100 decision trees per class. So if we go back to the notes now, the next note we have is that it takes the average entropy or information gain of many decision trees via bagging, which is what I've explained. And then bagging is short for bootstrap aggregation, meaning that samples are chosen with replacement and combined by taking the average. So this is important to understand because the difference between random forest and extreme gradient boosting, which is the one I'm going to explain later, is that random forest just replaces anything that doesn't need versus the extreme gradient boost that uses those errors, things we don't need, to learn from it and improve its gradient, which is what we are going to do later in the next step. And the way to run it now is that I call it from SKLearn, so random forest classifier. I set the number of estimators to 100. So what this means is the number of trees in the forest. So it's going to run this tree 100 times. And I set the criterion to entropy because the default one, if you read in the documentation, is Guinea. Right, the next thing is that I print the accuracy, so exactly the same thing as we've done in the previous video, and then we plot the confusion metrics. Again, we've explained this in the previous video. So it's just a copy paste of this code above here, down here. So what we observe is that the training accuracy is 100% just because it used the max depth, so it went all the way down with all the variables. And the testing accuracy is on 86%, which is higher, I think, than the previous one. Yeah, it's much higher. And then if we check our confusion metrics now, what we see is that we get 96% of the node churns correctly and 48% of the churns correctly. So let's see, did it improve? Yeah, it did improve our results, but very little compared to a decision tree. So what we're going to do now is that we are going to try to tune our hyperparameters to see if we can improve our results. To do this now, the first thing I do is that I import product, because we are going to use a combination of these parameters down here. Then I set the number of estimators to 100, so 100 decision trees to run per combination. Then I set the max features to 1 square and log. And if you read in the documentation, max features is the number of features to consider when looking for the best split. Then I set my max depths to none, 2, 3, 4, and 5. So this is to control overfeeding, and you can read about it into the documentation again, which is over here, the maximum depth of the tree. And if you leave it to none, then it's going to expand all the way until it uses all the variables. And then this is where I have my for loop. So what I say over here is that for F and D in product of max features and max depths, so F represents max features and D represents max depth, and this product is going to create all possible combinations between these two. Then I call and feed my model, and into my random forest model I set the number of estimators equals to this number of estimators above here. I set the criterion to entropy. I set my max features to F over here, which is going to start with 1. And then I set my max depth to D, which is this D over here, which is going to start with none. I set the number of jobs to 2 and a random state of just a random number. Then I just feed my model and I make a prediction straight away. Then I print the classification accuracy based on F and D. So what this means is that it's going to say classification accuracy on test, as you can see down here, with max features equals 1. So this one is the first max feature. So this one over here, which is my F. And max depth equals D, which is none, which is the first one, so the first possible combination, equals 86% accuracy, which is my accuracy I have over here. After this, I just copy and paste the confusion matrix from above. So I calculate the confusion matrix using this prediction test over here, and then I plot my confusion matrix. So now, if you run this, let's run it quickly. It's going to loop through every possible combination, as we've said. It's going to calculate the accuracy, and at the same time, it's going to plot our confusion matrix. So as you can see, this one over here is not improved. So the number I see the most is this number over here, because we want the business to predict as many churns as possible to avoid losing any business. So 45% is not good for us. Then we have 0. So this is terrible. This is not good. This is not good. This is not good. This is okay. So it's up to 50% now. And then let's check all of them. 19, 3, again 50% this one. Right, so the two best ones we have is this one above here, and you can see we are using max features equals to log 2 and max depth to none. So this one gives us a 50% correct predictions on the churns, and the other one we have is a 50% correct predictions with max features equals to square and max depth equals to none. So let's check again. So you can see we have improved our results. We've managed to push this 0.48 to 0.5 by tuning our parameters. The next step now would have been to take the parameters with the best classification accuracy on the churn and then run one individual random forest tree like we have above here, and then use that in the business. However, we are not going to do that. We're going to move on with eXtream gradient boost, but we have identified the best parameters for our random forest. Right, some notes on gradient boost now. Gradient boost is short for extreme gradient boosting. So this XGB you see is actually extreme gradient boosting. It is an ensemble model, same as the random forest, which means that you combine multiple different machine learning models into one. And as I was saying before, instead of aggregating the predictions, boosters turn weak learners into strong learners by focusing on where the individual models went wrong. So instead of replacing, XGBoost actually uses those errors in order to turn them into strong learners. And the last point I have is that XGBoost trains upon their residuals. So instead of aggregating entropy and information gain that we were doing before, gradient boosted trees learn from those errors during each boosting round. And if you want to learn more about how they work, I suggest reading these 3 documentation links I have down here. Right, to run it now, make sure you pip install XGBoost and also make sure you have the randomized search CV because we're going to need it later on. Right, the first step I have is that I call my classifier and I set my tree method to GPU_hist. And if you read in the documentation, the tree method is the tree construction algorithm used in XGBoost. And the reason I use the GPU hist is because experimental support for external memory, so GPU, is available for this GPU_hist. The next step now is to set our parameters, which are the ones we are going to loop through to search and find the best possible combination that gives us the best outcome. So I start with the learning rate, so how fast we want our model to move. Then I set the max depth. Again, you can read about this in the documentation, but we have explained the max depth a lot of times. So it's the maximum tree depth for base learners. Then I set the mean child weight to 1, 3, 5, and 7. And if we read about this, the mean child weight is the minimum sum of distance weight needed in a child. And then I set the gamma values, so different gamma values. And if we read about this, is the minimum loss reduction required to make a further partition on a leaf node of the tree. And then I also set some call sample by tree values. And again, if we read about this, this is the one over here. So it's the subsample ratio of columns when constructing each tree. Next, we are going to use this randomized search CV, which is an SKLearn library that searches through hyperparameters. So it's a randomized search on hyperparameters that gives you the best possible combination. Just because there is a lot of combinations between these parameters, we cannot replicate the same for loop we've done above here. So to use this library, all you have to do is call it randomized search CV, fit the classifier, which is our XGBoost classifier we've just created above here. Then we need to set the parameter distributions into the parameters we have just passed above here. So these are all the possible combinations. Then we want to set the number of iterations to 5 and the scoring to the ROC curve. So if you read about the scoring, so if we go down here, this is the parameters, this is the scoring, and then if we find the ROC curve, just to show you so the options you have, it's all these options here, the scoring option, so how you want to score your model based on which metric. And the reason I'm using the ROC curve is because ROC curve is the ideal point. So if I find it quickly, which one? Let's try this one. So it's the ideal point between the true positives and the false positives. Just because I want to make sure that I predict more churn, so this number down here correctly. And the last thing we have to do now is just to feed our randomized search CV into our X and Y. So as you can see down here, we are not using the X train and Y train. We are feeding it in all the data. And if we click run now, it's going to loop through every possible combination of these parameters and search for the combination that has the best ROC curve. And in order to get the best parameters now, so the ones that identified as the best parameters, all we have to do is run this code over here and it's going to give us the best values. So for mean child weight, it's 7. So if we come up here, it's this number over here. And then for max step 6, and then learning rate 0.05, for gamma 0.3, and then for call sample by 3 is 0.5. Now what we should have done is go back and run another XGBoost classifier and then feed these parameters down here. However, XGBoost made it easier for us by giving us this function over here, so .bestEstimator, which gives us the model ready to go. So we can copy this as it is and paste it down here and name it as a final model and run it. And if we check the parameters within the model now, they are already fed to the best parameters above here. So if we check the mean child weight, it's over here, you can see is 7. And then if we check the max depth, it should be 6. So max depth equals 6. So if you check all of them, they're going to be the best parameters. So we copy this, we paste it down here, and then we run it again. Then we are feeding our model with the best parameters, and then we make a prediction based in this final model. And the last thing I have is that again, I copy and paste the confusion matrix from above and I plot it down here. So if we run this again, you can see that we have improved our results from random forest, which was only on 50%. Now we've managed to push it to 51. It's not a big improvement, but it's still some improvement, and we still need to experiment and try to improve our results as much as possible. Right, now that we have our final improved model, we want to deploy our model on some new and seen data. So imagine we are in a business and then our manager comes to us, data scientists or data analysts. They tell us that we have some new data, some new customer data, and we want to predict the probability of our new customers leaving the bank. So I want to predict the churns. So the first step we have to do is to load the raw data into Python, and I am using SQL in this query, but you can do exactly the same thing. So load exactly the same raw data from a CSV file, which I'm going to have in my GitHub repository. And if we investigate this new raw data now, what we see straight away is that we do not have an exited column. So because these are new customers, we don't know if there are churns or not. This is why we need our model now to make predictions to see if there are going to be churns or not. The next step now is to apply the same pre-processing steps that we have applied in our previous data we have used to train our model. So if you've watched part 1, it's literally a copy-paste of the steps. So the first thing I do is that I limit the data. So I exclude the row number, the customer ID, and the surname, as you can see over here. The next step is that I turn my categorical variables into numeric representation by using get dummies, so zeros or ones. And the last step I have is that I scale my numeric data. So I scale credit score, estimated salary, balance, and age into values between 0 and 1. So the new raw data looks like this, which is exactly the same as the eXtream data that we have used to feed into our model. The next step now is to use this new raw data to make predictions. So down here, what I have is that I say predictions underscore XGBoost equals final model dot predict, and into the dot predict, I take this data frame and I take the values as inputs. So this final underscore model is actually the model we have just created above here using the XGBoost algorithm. So what this is going to give us, if I run it, which I have down here, is zeros and one depending on the customer. So for the first observation, it's going to tell us if it's a churn or not. So this is not a churn, this is not a churn. But the third one, we predict that this person over here is going to be a churn. The same way we've predicted zeros and ones, we can actually predict the probability, which is what I've done down here. So the same way you call .predict, you can actually say .predict underscore proba, which is a probability, and fit the same data frame. So this is the same data frame, and this is going to give us the probability. So if I run it down here, which I have, it's going to give us the probability of the first person to not be a churn. So this is 0, and this is a churn. So this is 1. So as you can see, the threshold is 0.5. So the first person is a 0. The second person is a 0. As you can see, the same data above here. But the third person has a 94% probability of being a 1, so a churn. So this is why we have 1 over here, which is a churn. And then the last 3, as you can see, is not churn, not churn, not churn. So not churn, not churn, not churn. So this is the predict probability. Next, I create a function above here that takes this array and separates it into 2 columns. So if you give it a 0, it's going to give you the first column. And if you give it a 1, it's going to give you the second column. And all we care about is this second column. So the probability of the customer of being a churn. And the reason I've done this function is so I can pass it back in the data frame, as you're going to see down here. So now I need to join the raw data with our predictions, with the predictions. So when I say the raw data, I mean this raw data above here before we scale it and we also change it into zeros and 1. So I take this unseen data. If you follow the steps, I create a copy of it. Then I pass the predictions, so zeros and 1. So these predictions above here, so this one, which is zeros and 1, I just pass it under predictions / churn or not, which is going to be this new column above here, as you see it, zeros and ones. Then under probability to churn, I pass this function I have just created. So this column predict probability underscore xgboost, 1. So this is going to pass the probability of the customer being a churn. As you can see, the third one has a 94%, as we've said, and it is predicted to be a churn. And the last thing I do is that I create this new empty column, which is called churn or not description. So this is actual text, which we are going to use for our dashboard in the next video. We need this. Then into this column, I'm saying that if the predictions churn or not equals 0, then is a retention, so not a churn. And if it equals 1, then is a churn. So this creates these retention and churn options for this new column. And the last thing I do is that I export the data into a new table in my SQL server. But if you don't have an SQL server, then you can simply export the data in a new CSV file. And this output, this raw data we have just created, our predictions, is what we are going to use to build this Power BI dashboard in order to communicate our results with the business. Because we cannot tell them to go and run some Python code to see our results. We need a way to communicate it easy to the business and something we can scale, because not everyone knows Python and not everyone understands Python and not everyone is going to have Python installed on their computers. So with Power BI, you can just send them the link and all the managers will be able to see your results, your predictions from your models. So straight away, the manager can come into this dashboard, see our potential ads, and then come down here in the customer details, filter this table with everyone that has more than, 45% probability to churn, and then focus on these people in order to make them not to churn, to retain as much business as possible. Right, data friends, this is it for this video. I'm going to show you how to build this dashboard from scratch in the next video. So I hope you've enjoyed this tutorial and you've gained enough value out of this tutorial. And if you feel like you did, I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos. If you have any questions, please let me know in the comments below. Otherwise, thank you very much for watching this video, and I'm going to see you in the next video.